Hi, I'm Adolph Oliver, and this is a video that introduces us to the idea of finding the slope from a graph. And we've been talking about rate of change. That exactly is what slope is. And graph lines show this very easily. First thing we need to do is talk about slope as engineers introduce it to us. And this is simply done by saying that the slope equals rise over run. Now, rise over run. We make ourselves an XY axis here, and let's do that. Here we go. X going to the right as usual, Y going upstairs. Then the rise is going along the Y direction. That's the rise. The run, I just run in the horizontal, is along the horizontal direction. So when we talk about slope as being rise over run, we're talking about how it changes in y compared to how it changes in x. Well, we'll show you some good examples of this shortly. But first, let's talk about some slopes that you just want to be familiar with. If you have a line that comes across like this, that's flat, and it can be anywhere, here, up here, anywhere on our graph. This line like this is not going uphill, and it's not going downhill. So the slope m equals 0. It's flat. Likewise, if you have a line that's going straight up and down, and it can be anywhere in here, then the slope on that is defined as infinity, and usually we talk about it as being undefined, which means we can't write an answer down for it. So two of the slopes that we want to be familiar with, a slope that's flat, m equals 0, a slope that goes straight up in the air, m equals infinity or undefined, but there are two others that are good references. One of them is a line that's going upward to the right at 45 degrees. Okay, so 45 degrees here is half of our 90. And so here's the idea. It's going from upward from left to right. We always talk about slope as going in the direction of the positive x-axis from left over here to right. And if you're going up at 45 degrees, then you have a positive slope when we say that m equals plus 1. Now this 45 degree line can be anywhere in here as long as it's going upward to the right at 45 degrees. Likewise, there's another one we want to be familiar with, and that's one that comes downward at 45 degrees. Okay, coming down this way, down at 45 degrees, and the slope here, since it's heading downhill, is m equals negative 1. So there are four slopes that you want to be familiar with. We use these as signposts. Again, any flat line, m equals 0. Any line going straight up, m equals infinity or undefined. Any line going upward to the right at 45 degrees is plus 1. And any line going downward to the right at 45 degrees is minus 1. Now here's one thing to point out about slopes before we go on. When you start out with a flat line at 0 slope and start tilting it then upward so it has a positive slope, you have to go from flat all the way to 45 degrees to get to just positive 1. After that, it goes up much faster. Positive 5, positive 10, positive 20, positive 50, and then straight up, positive infinity. Likewise, if you start out with a flat line and start tilting it downward to have a negative slope, you have to go all the way to 45 degrees to get to just minus 1. And then after that, it increases much faster. Minus 5, minus 20, and straight down minus infinity. So the changes in slope accelerate. We go from 0 to 1, 45 degrees up to positive infinity, and then from 0, 45 degrees down, m equals -1, and straight down, negative infinity. Well, these are 4 slopes that you want to remember. We're going to use those as references as we go along. But now let's take a look at how we can actually find the slope from graphs that we have. Okay, here we go. Here's a line which is going upward to the right. Okay, since it's going upward to the right here, okay, then since we always think about slope as going from left to right, this is going uphill. If it's going uphill, it then has a positive slope. So this is one of the things you want to make sure is that the slope value that you come out with here is indicated as being positive. Okay, here's a way that we can work this. Pick any 2 points on the graph line that go through the corners of some of our grids so it's easy to get the values. Here's one here that would be good. Here's another one right here. Here's one right here. And there's even one up here. We got at least 4 of them here that we could make use of. Any one or any pair of these would be all we need. Let's just take the 2 in the middle here. And here's what you do. Make yourself the triangle that fits just underneath this. Okay. Here we are. I'm taking this point here and this point here. Well, we can simply find the rise and the run on this. Remember, of course, slope equals rise over run. This is something you definitely want to remember from the engineers. Well, here we go. The run is the horizontal change. And if we take a look, starting with our left point, working over toward where the right is, we got to go 1, 2, 3. So the run equals +3. Now, the rise, the other side of our triangle here, 1, 2 is +2. So the rise equals +2. Okay, well, we've got the rise equals 2, the run equals 3. Those are both positive. The slope is 2/3. And of course, remember, that fits what we just talked about. If the line had been going up at 45 degrees steeper like this, it would have been +1. Well, this is a bit less than going up at 45, so our slope of +2/3 looks real good. Okay, let's take a look at one that's going downward. Okay, here's a graph line definitely heading downward to the right. So since it's going downhill, remember we always look from along the positive x direction here from left to right, so it's definitely heading downhill. Then that means it has a negative slope. Okay, well, once again, what we're going to do is use the old engineering formulation. Slope, okay, equals rise over run. Well, how do we do this? There are different spots on here that we could pick. Remember, you can choose whatever points you want to use to find this out on the line, but notice they've already indicated a couple of them here that go right through the corners of some of our grid points. This one right here and this one right here. It's just much easier to figure the rise and run differences using ones that are right on the grid lines. And of course, it's your choice which ones you pick. You'll get the same slope no matter which ones you pick. So pick ones that are easier for yourself. Now, once again, make the triangle that would fit underneath these guys. Here it comes down here, and here it would go right over here. Okay, here's our triangle. This is the rise right here, and this is the run right here. Well, let's take a look at the run first. We're going to go 1, 2, 3, 4, 5, 6. The run equals 6 units. Okay, and the rise, now notice we're going downhill. So this is what makes this thing a negative slope. 1, 2, 3, 4, 5. Rise equals -5. Okay, well, again, we picked 2 points that were easy to count to, drew our triangle in underneath. The rise was 5, the run was 6, but the rise was going downhill, so the rise is -5, the run is 6. Our slope is negative, like we said it should be, and about the only thing to do here, the best place for the single minus sign in the final answer, just put it out in front. So we'd say the slope equals -5, 6. Well, finding slopes using this triangle method is an easy thing to do. Now, there are a couple of these guys that should just plain remember from the references that we had. You don't need to do any calculations on. Okay, here's a line right here which is clearly flat. Okay, so this is a flat line. Okay, it's not going uphill, it's not going downhill. So remember, as we talked earlier, any line that goes flat straight across our XY grid, the slope is simply m equals 0. You don't need to do any calculations, you just remember that. Well, likewise, if we have one that goes straight up in the air, here it is. Okay, here's our XY grid again, and here's our graph line right here. Any line that heads straight up, and it can be anywhere in here, doesn't have to just be over here. But anyway, any vertical line that we get, okay, then you just remember it's m equals, you can either say infinity or undefined. Undefined means we can't write the answer down. The number's impossible to write because it just keeps on going. And infinity indicates the same thing. Okay, well, as we see, it's very simple then, given a graph line, to be able to find out what the slope happens to be.